Now let's look at this problem called climbing stairs. So this is a relatively easy problem. Um, I think it's it's among the problem that are solved by most teams. The programming part is fairly straightforward. I guess the toughest part is actually to understand what the question asks. If you read the description, it's actually takes some time to understand what it means and even to understand how the sample input works. But in essence, um, what happens is we want to calculate how many number of steps one needs to take, and every day one enters the building at the ground floor, and then one has to go up to the office, which is k steps up. And then he also needs to visit a registration desk that's r steps up, and he can visit this in any order. Um, and At the end of the day, he will come down, so walking some number of steps of stairs to ground floor again, and then leave for home. So the actual requirement is that we have to walk at least n steps before visiting the registration desk. So if by visiting my office and then to the registration desk, the number of steps is less than n, I have to walk a little bit more. So this can be achieved by going up a few extra steps and then coming down to registration desk again, or going down a little bit and then up to the registration desk. So let's just walk through the sample input. So n is 20, so that means we have to walk 20 steps before visiting the registration desk, which is at 10 steps up, and the office is 5 stairs up. So then what we need to do is we will first go to the office at 5 steps, and then another 5 steps we can reach the registration desk. Let's say we visit registration desk at the end of the day. So we first spend all day in office, and then we go to registration desk. At that point, we have only walked 5 stairs. So that's not enough. So we need the 20 stairs. So we can walk 5 up more and then 5 down. Then at that point, we satisfy the requirement. So we visit registration desk. And at that point, we have visited 20 stairs. And we still need to go 10 more stairs to the ground floor to go home. So the answer is 30. So there are a few ways to do this problem. One is you can do case analysis. So there are at most 6 cases based on the ordering of KRN. And you can think about, within case, there may be extra thing you need to do. But you can think about for each of the case what actually happens. But either after you do that or before you do that, or at some point you may realize that what matters is whether n is less than or equal to max of kr, or n is greater than that. When n is less than or equal to this, then you don't need to worry about this requirement 3. You just need to go up to the max of this and then coming down. And while you come down, you visit the registration desk and then you go home. So the answer will just be the max of 2k and 2r. So the case that n is greater than this is a little bit tricky, because that means that if your natural flow of going up to the highest of k and r it's not enough for n, then you need to walk some extra steps, and then you go back to r. And here there's actually a little bit extra trickiness. There's a parity issue here. So when n and r are not the same parity, then you actually need to walk an extra step. So for example, the example on the bottom of the slide, if r is 11, so k is some small number. Let's say k is 1. So when we go to r, we only walk 11 steps. So it's less than 12. So that's not good enough. So then we need to go somewhere else. If we go up 1 step, we are at 12. But we still need to go back at R. So then the number of steps we need to walk before reaching R for the last time and then go home need to be 13 for this case. But essentially, if N and R are of the same parity, so then we can walk exactly N steps and reaches R. If N and R are different parity, so they're one odd and one even, then we need to walk one extra step. So that's essentially what it is. So essentially N prime will equal R when they're the same parity, and otherwise N prime equals N plus 1. And the answer is this.